Hello, MLM class. Today I'm bringing you a presentation about three-level models with longitudinal data. So let's take a look. We're going to start by looking at what a three-level model is, what's the nesting structure. We'll talk about the formula for the intra-class correlation. And then in these models, when we include a treatment, the treatment can occur at different levels. And so this will be some differences in how we formulate the model and what the model means, and why we may do that. And then, of course, we'll look at an R example. So three-level models with time. In all of these situations, the measurement occasion will be the lowest level, level 1. And so some examples of this would be patients, which is level 2, measured in time, level 1. And then these patients are clustered in therapists. And so that is the third level. We can also have a situation where children measured at multiple time points are clustered in schools, or people measured at different ages clustered in universities or jobs. So when a treatment is involved, like I said, it can occur at different levels, and we will get to that in a second, and this will complicate the design a bit. So for the intra-class correlation formula, this is no different than last week. It just means something different. And so we estimate an empty model here where we have an outcome variable which varies at the measurement occasion level, which is I, an individual level J, and a cluster level K. We have our fixed intercept, which is the average intercept. We also estimate a variance of level 3 here, VOOK. We estimate a variance for the subject, and then of course we have a variance at the measurement occasion level, just our overall residual. And so these variances, which are represented by sigma squared, are variance of the measurement occasion, so our residual, everyone's deviation from the expected values, each person and time point. The variance of the individual, so within each person, and then which within each school. So we account for the variances at each of these levels. Because we're doing this, the overall variance is going to be the sum of those. That is all of the potentially explainable variance. And so when we compute the level 2 intra-class correlation, we are going to divide the variance attributable to the individual over all variance. And this is very similar to what we're doing when we just have measurement occasions nested in participants. But this is telling us the variance that can be explained in the individual trajectories in time by the people. If it is high, this is telling us that individual characteristics of the subjects are driving their trajectories. If it is low, it could be telling us that this phenomenon is largely controlled from outside of the individual, and that the individuals have similar trajectories. Could be time varying or cluster. Now the level 3 cluster variance here, where we take the level 3 variance divided by all variance, is giving us an idea of how much of the unexplained, how much of all variance is explained by the level 3 cluster membership. So if we have participants measured in time, nested in therapists, if this is high, this is telling me that a lot of the variance in the outcome variable is explained by the individual therapist, meaning that there is some therapist level effect for us to explain. So let's get ready to take a look at some models here. And I have a figure I found online for you that I think is a good way of representing this nesting structure. And so we have 2 therapists here, just for an example, and each therapist is just going to see a subject, right? Therapist 1 will see subject 1 will not see therapist 2, and vice versa. Subject 2 will only see therapist 2, subject 2 will not see therapist 1. And then these subjects are measured at multiple time points on some treatment outcome, say depression. So this is going to be the simplest longitudinal 3-level model. We have no treatment effect yet. We're simply going to model the trajectories, see if any development occurs of these depressive symptoms. And so this simple model will just have a random intercept at 2 and 3, and here's our time vector, okay? So by substituting this equation in, we end up with the following full model. And this is very similar to the empty model we use for the ICC, except now we are including a fixed slope of time. So pretty much what we're doing here is saying that all of the participants are varying across time, and we are going to explain the outcome variable here with this relationship in time and accounting for the expected means of each level of clustering. So we have the overall expected mean of all participants at time 0, the overall expected mean of the variance of the overall expected means due to the therapist, and then the overall variance in the expected means due to each individual client. Now, this is helpful because if you look at our nesting structure here, if we just ignore therapist, we're leaving a piece of the puzzle out. We could ignore the therapist level effect if only one therapist saw all of our subjects. But because we have multiple therapists, we need to consider the fact that these therapists may have different abilities. They may have different characteristics. And so we need to take them into account somehow. A random intercept in this case is the simplest way of doing that, leaving us with this full model here. So we can complicate things and add a slope, random slopes. Now, again, like I say in each of my lectures, don't let this overwhelm you. Just take a look at the level 2 formula, for example, and note that we are now saying that the slope or the relationship of time related to the outcome varies as a function of the participants. But now we're also saying the participants' relationship with time, or the measurement occasions here, varies as a function of the therapist. Okay, and so when we substitute all of this in, gamma 00k, these terms go in to the gamma 00k here, and this expands. And the gamma 10k goes into the level 2 here, and this expands. And then that expanded formula just gets plopped in here, right? And you can see this is where the cross-level interactions happen. And we see the relationships between the variances at each of our levels with time, which is our time vector here, t. Okay. So that was a simple case where we didn't have a treatment condition. But things get a little more complicated with the addition of a treatment. So let's first take a look at this situation. Here in this diagram, we see we have multiple therapists. We could have a situation where therapists are administering different therapeutic frameworks. So therapist 1 and 2 may be doing dialectical behavioral therapy, DBT, whereas therapist 3 and 4 might have some controlled therapeutic behavior that's already been investigated. And so in this situation, the therapists 1 and 2 will be exposing the treatment to all of their subjects, and therapists 3 and 4 will be exposing the control condition to all of their subjects. So treatment at level 3. Now I know this formula gets a little explosive here, but really all that we're adding to the intercept and slope formula we saw in the last set of slides is this term here, which is G sub k. This is my level 3 treatment condition. We see it right here, level 3 treatment condition. It's a 0 or a 1. If the therapist had the treatment, it's a 1. If it didn't, it's a 0. And so what we're doing is we're explaining the individual differences here, gamma 1, 0k, which explains the slope down here at level 1 of the individual time differences. It also explains GK, the level 2 intercept, gamma 0, 0k, which is explaining the level 1 slope intercept down here, okay? So what we're saying is we are allowing the intercept and slope at level 2 and subsequently level 1 to vary as a function of the treatment effect. Now this formula does blow up a little bit. And so what we have is our traditional fixed intercept down here in the full model. And this is because these cross-level interactions. As we substitute, we need to multiply these terms, specifically the slope term here. And so this is just simple algebraic substitution, just like it was earlier. So we have the fixed intercept, the overall intercept of time. We have the therapeutic effect at level 3, the slope of the therapeutic effect. We have our variance terms. We have the slope time interaction. This is the level 2 time interaction. We have the time interaction of variance of the slope variance of time. We have the level 3 time intercept of the slope variation. We have the primary term of interest here, which is going to be the relationship at level 3 between the treatment conditions and time itself. So this is the difference in the slope of time related to the outcome variable, and that difference is based on the treatment condition, which under this design, I would say would be the hypothesis of interest, right? Based on these treatment and control conditions, which one sees a stronger development over time of whatever we're measuring, depression. Okay, now, why all of these other terms then? Well, a lot of these terms we need to make sense, right? So this is a three-way interaction of treatment and time, a two-way interaction of treatment and time at level 3. Remember, we need, when we make interaction effects, we need the subsequent or prior interaction effects for these to be interpreted to make sense. And so that's why all the lower order effects are included here in this model, even if we only really care truly about the fixed difference. We need to estimate the variances around them to account for the level 3 and level 2 cluster differences. In other words, the therapist level effect. We need to take into account that these therapists aren't seeing all of the subjects, and 1 may be just better than 2, or 3 could be better than 2, or any combination of this. Also, in this 3-level model, some subjects might just be more prone to recovery than others. And so this multi-level model takes those differences in variation into effect, and it allows into account, and it allows us to interpret the effects of interest even though we're nested in this clustering. Okay, great. So we could also have a situation where the therapist could be doing both a treatment and a control. So therapist 1 in this situation is providing a treatment condition, DBT, to subject 1, and the control condition to subject 2. And so in this formulation, we've now methodologically accounted for the fact for part of the therapist level effect, right? So in this design, we can't take the therapist's effect of the condition here out because each therapist is either a treatment or a control therapist. But in this design, each therapist is a treatment and a control. So this methodologically allows us to control for therapy level effects. And in this formulation, because level 3 has been is being controlled for by the therapist, we are now introducing the treatment effect at level 2 effectively. Because here you are either a treatment subject or a control subject. Regardless of which therapist you're going to, each therapist has a treatment and control subject or set of them. And so now, because we're putting the level 2 cluster effect at the individual level, where a participant is either treatment or control, but therapists are accounted for in that, we now have to add different level 3 predictors here, which account for this control condition effect. And so this is how the model formula plays out in this situation, where we have our level 2 random slope, random intercept, but now we also have, above and beyond the level 2 cluster specific intercept and slope specific intercept, we have slopes related to the outcome, to the treatment variable here. And now at level 3, we need to account for the variations of the interaction here with the treatment effect of qualities regarding to the therapists, right? So we now know therapist 1 might be better at administering the treatment than therapist 2, which is why we're accounting for the variance in the relationship between the treatment and the outcome in time of each of the therapists. And so while these designs may look similar, statistically we control for them in different ways. And you may be motivated to use different designs depending on your scenario. I would say, and this isn't universal, this is going to vary by situation and topic. If you think that the treatment can be applied relatively equally by all therapists, this design is going to be easier to administer. But if you think there may be some variability in how therapists administer treatment and control, this design may be easier to administer and control for statistically. Okay, guys, that's great. So now we are going to move on to an example in R. Thank you very much for following along. I'll see you in the other video.